Hello everyone, my name is Javier Ramirez Moral and I am going to present you my final project of the course CS50's Introduction to Programming with Python. I have called it Image Classifier with AI. So this project implements an intelligent image classification system using TensorFlow and the MobileNet version 2 model, optimized for performance and efficiency in resource-constrained environments. I want to go beyond the basics requirements by incorporating a robust architecture, automate testing, and a user-friendly experience via both command line and web interfaces. The goal is to allow users to load one or multiple images, process them, and receive high accuracy prediction about their content, and with a friendly interface and options for result traceability. So first of all, we need to install all the requirements that we need to deploy correctly this project. In my case, we use TensorFlow, NumPy, PyTest, Radio, and Pandas. And also we need to have, for example, I have here in assets, different types of images that we use um, to test our model. For example, different topics, animals, food, and objects. So now we are going to see the code. If you want to consult and see detail this code, you can do in my GitHub repository that I leave you in the description of this video. So we need to start to import standard libraries and third-party libraries. Then we have the configuration setting. Basically, this block of code is for configure environment to suppress TensorFlow logs and warnings. Then we have the model initialization, load mobile net version 2 model with image net wakes only once for efficiency. Then we have the core function. The first of all is the load and preprocess image function that basically loads and preprocess an image for the model. So use keras image load image to load image in the properly resolution for MobileNet version 2, converts the image to non-array and adds batch dimension and applies the model specific processing, so the normalization we say. Then we have the classify image function that classifies an image using the preload MobileNet version 2 model. So use MobileNet version 2 to predict method. The code prediction converts numerical outputs to human readable classes and returns top 3 prediction by probability. Then we have the display prediction, so format prediction result for display. Basically process its prediction tuple, replace underscores with space and capitalized words, and formats probability as percentage with two decimal place. Then we have the utility functions. The first of all is the save to CSV, so basically save classification results to a CSV file in Excel friendly format. Then we have the GUI interface, create an enhanced UI interface using radio. So uses radio blocks for flexible layout, example image for quick testing, automatic web browsing, uh, automatic automatic browser opening and emoji enhanced result display. Um, then we have the predict function. So basically, this function handles the entire image classification process. It starts by checking if an image was uploaded. If not, it returns a prompt asking the user to upload one. Then it loads and preprocesses the image, so it's compatible with MobileNet version 2 model. After that, the model predicts the top 3 classes, and the results are saved into a CSV file for historical tracking. And finally, the predictions are formatted with emojis for a user-friendly display, and both the image path and the formatted results are returned to update the interface. So then we have the function batch process. So basically process multiple images in batch mode and returns classification results. For example, I have here my my code test. So if we execute, for example, this test, so here we have our output with the two images that we used, for example, with his predictions. And then finally, we have the main application. So main entry point for the application. So basically, clears console before starting, provides CL and UI modes, handle user input validation, and manage the application flow. I have also implemented unit tests with PyTest to ensure that the core functions of the project are working correctly. This is my test project, my file test project. And for example, if we want to test the code before execute it, we can run PyTest on our file, and we can see that it is all okay to execute our our mainly file. So 3 passes, okay, it's all right. Okay, so now I am going to start the program in the UI mode to show how the graphical interface works. So if we execute the program, they say what you prefer, CLI or UI mode. I say that we want to graphical interface, and the interface will open automatically in the browser. So now I am going to load a sample image from the assets folder. For example, let's say here in objects, a car, and we say classify image. And here we can see the classification results. The model has correctly identified the image category. So in the top three prediction along their probabilities, sport car, race, or car wheel. So it works fine. And for example, if we come back here, we can see that additionally the results have been automatically saved on a CSV file called results. So we can check this, the day, the image, the name, the top prediction, the second, and the third. So you can have this traceability of your test. Now I am going to show you the CL mode. I am going to start the program. Sorry. You can see now the system asks whether I want to use CLI or geo mode. I will type CLI to select the command light mode. And here we can, the program is asking you to for image path. So I am going to load a sample image, in this case, for example, a dog. So the program will classify the image and display the results. Here we can see the top three prediction for the model along the probabilities. The model has correctly identified that it is a dog. So the image that we use in this case is this one, that it is exactly a golden retriever. And like we said before, additionally, the result has been automatically saved in this result CSV. So to wrap up, here is a quick technical recap of the tools and technologies behind this project and a look of what could come next. So we need to use TensorFlow, powers the AI core. It loads the mobile net version 2 model, handles image pre-processing, and turns RAM prediction into readable labels. Mobile Nets version 2 is our go-to model for image classification, fast, lightweight, and pre-trained over 1000 categories thanks to the ImageNet database, ideal for quick real-time predictions. Next, we have Gradio, makes it accessible, offering a clean and intuitive GUI where users can load images and see results instantly, no code need. And behind the scenes, standard Python libraries like AO, CSV, and Datetime help us manage files and keep clean record of every prediction. Looking ahead, there are several ways we could improve this project. For example, integrating other models like FNCNet or custom training network for better accuracy, adding support for drag and drop image uploads or webcam input, developing the app online with tools like Hugging Face Spaces or Streamlit Cloud. And together, these tools make building practical user-friendly apps not just possible but easy. And that's it. I hope you like it and encourage you to do your own projects. So thanks for everything. It has been a hard trip, but it was worth it. Bye.